So today we're going to talk about motion. So here we have a truck. Say it's middle of winter, blizzard, you can't see anything. You look outside your window, you notice that there is this mail truck, and this is all you see over here on the left-hand side. You're like, man, I'm hungry. You go make a pizza and watch a TV show, and you come back, and as you're getting the pizza out, 30 minutes later, after you're done eating and putting your stuff away, you look over and it's like, oh, wait a minute. There's that mail truck again. Has the truck moved? Well, what about now? What if, same scenario, make a pizza, come back, before it looks like this, afterward, you see this, has the truck moved? And the answer would be yes. Can you tell if the truck has moved here? No, you can't, because all you see is the truck. Here, you can say, well, how do you know the truck's moved? Well, in the beginning, you've got the mailbox in front. Afterwards, you got the mailbox behind. So you definitely see it. It's moved. That's because motion is a change in an object's position, relative, and this is key, to a reference point. The mailbox was a reference point. Now here we have a picture of a person on a field here. What is the distance that he traveled, and what is its displacement? Well, first of all, we got to talk about what exactly are these two. Well, displacement is the distance and direction of the object's change in position. And distance is how far the object has traveled. So if I start here, I can go all over the place. I can travel, twice as far, but my displacement is going from point A to point B. It doesn't matter what I did to get there. It's just my starting and my end place, that distance. So in the questions asked before, what was the distance traveled? Well, total distance traveled would be from 0 all the way to 50, then back here. So that's 80. So 50 plus 30 is 80. But the displacement is the starting from point A to point B, from start to finish. This person only traveled 20 meters. Well, speed. Motion often includes speed, right? And speed is the distance an object travels per unit of time. The equation for speed is distance divided by time, where v represents the speed or velocity, and d equals distance, and then t is time. Well, speed can be broken down into different types of speed. So, for example, you have instantaneous speed. Instantaneous speed is the rate of motion at a very specific time, right? So if you're driving along, you look down at your speedometer, that's how fast you're going at that exact moment in time. Where do we use instantaneous speed? Well, when you're speeding. If a police officer pulls you over, the radar gun showing, oh, this is how fast you were going when I clocked you. Another example would be Matthews bows. All right, so if you're a hunter, which actually travels at 353 feet per second. And then, of course, we have for baseball or softball fans, how fast are they throwing when the radar clocks that ball? Fun fact: 77 miles per hour is right now the record for the fastest softball pitch. Okay, then you have constant speed. Now, constant speed is something that does not change. So, for example, if you had you're driving along and you put your cruise control on, that would be an example of constant speed, or maintaining a constant speed. Then we have something called average speed. Now, an average speed is taking the total distance traveled divided by the total time of the travel. This is used when your motion varies a lot. So like in the example here, riding a mountain bike in the mountains. If you're going up hills or down hills, your speed is going to change a lot where you're traveling. So you're not going to use instantaneous speed to describe your travels, right? You're not going to say, well, at the first minute I was traveling at 1 mile an hour. And at 2 minutes I was traveling at 3 miles an hour. At 4 minutes I was traveling. No, you say, well, someone says, how fast were you traveling? I was traveling about 20 miles an hour or 10 miles an hour. So graphs here, we take a look at when we're graphing this type of information. On the left-hand side, we're going to have your distance, and time is going to be on the x-axis. So for constant speed, we have here is a straight line from 0 to whatever time. So for every unit of time, you're going to have a unit of distance. Here we have on a motion graph here a flat line. This flat line represents no motion. All right, so from 0 to whatever set of time, the distance has not changed. If distance hasn't changed, there's no motion taking place. Now here in a motion graph, here we have our unit label or distance here, measured in meters. Here we have time. So we're going a certain amount of distance, and now we're going smaller over a period of time. So now we're walking backwards. So here we have a graph. And on this graph, you're noticing a couple of things. First off, you're seeing a green line that shows a fast, steady speed moving from 0 to 100 miles. All right. So this is a constant speed, but fast. And then the blue line shows a journey that initially isn't quite as fast, stops for a while, and then constantly or steadily comes back to the starting position. And then last but not least, you have the red here where you have an inconsistent or not a steady speed, where the journey here, you're after about 2 seconds here, there's an acceleration where you start to get faster and faster and faster and faster, and then here you start to get a little bit slower because the curve of this line, it's not going up, you're not traveling as fast as compared to the beginning. So if looking at this, what part of the graph here represents someone that has stopped? Pause it. Answer would be letter C. If we take a look at here, which parts here represent something showing a constant speed? Answer, A, B, and D. Although, which of these has someone walking away from the starting spot? Answer, A and D. B, the person is coming back towards the starting position. That's all we have for today. The basics of motion. If you want to look at more of the resources and videos found in the slideshow, click on the description at the bottom and click on that link to take you to the slideshow where you can get more information